What's going on YouTube? This is IppSec and we'll be doing Jail from HackTheBox. This box is pretty tough because it involves piecing together a lot of small exploits to get a user shell. Once you get a user shell, then you have to escape the SELinux jail, and then the Privesc to root is pretty straightforward. The exploits you got to chain together. You got NFS listening version 3 that allows user ID spoofing. The web server is exposing source code to a C application that you have to buffer overflow. There's an IP table that prevents reverse shells, so you have to socket reuse. And even after all that, you get a shell on the system, and you have to use SELinux bypass to get to a regular user. And the Privesc is just, I think, abusing Vim and a RAR file. It's been a while since I've done this box, so let's jump in. For this box, we're actually going to do two different NMAPs. So the first NMAP is going to be in all ports. So nmap-p- to scan all ports, -OA, give it a file name, and we'll call it all ports. The IP address of jail follows that with 10.10.10.34. If you want to speed it up, you could do T4 or T5 to speed up the scan. Looking at the results of that, we see it has a few ports open. So with those ports, we're going to do a second nmap scan and just enumerate the version and run safe scripts. So nmap-sc -sv, that is safe scripts enumerate version, -oa, we'll call this one basic-scripts, and -p to specify the ports, 22, 80, 111, 2049, 7411, and 2048. After that, we can put the IP address, which is 10.10.10.34. Looking at the results of that, we have nothing really interesting for SSH. The web on port 80 is very interesting because it's telling us Apache 246 CentOS. Just like IIS on Windows, this tells us essentially what flavor it is. By IIS version, you can guess like 2003, 2008, 2012, 2016. With this, we can guess CentOS 5, 6, 7, etc. So to do that, let's go over to Google and just search Apache HTTPD 246, and I'm going to put RHEL, R-H-E-L. CentOS is just essentially a fork off RHEL for free. RHEL is the paid version, so naturally it has better documentation. And the reason I do HTTPD is because that's another name for Apache. Let's check out the first two links, just in case the first one doesn't have what we want. Scroll down, let's search for 246. And this doesn't look like it's the blog post we want. Search this one. And we have it here. So, Apache HTTP servers included with currently supported products. RHEL 5 is 223, RHEL 6 is 2215, and RHEL 7 is 246. So we can guess that our target box, Jail, is going to be version CentOS 7. Next thing, we have NFS, and we see NFS version 3, so we can spoof user IDs there. That is definitely key, and we'll get into that in a little bit. 7411, we don't know what port this is, and 2048, or that's 20,048, my bad, is probably related to NFS as well. We see Mount D. So going out of the Nmap, let's just check out the web server on port 80. So let's go to 10.10.10.35 or 34, and we see just jail. Nothing really interesting there. Looking at the page source, it's just tags. So again, nothing interesting. May want to do like robots.txt and not found. So don't really get anything. So let's open up GoBuster and DirBust this page. So go down one directory, and let's look at the options for GoBuster, because I don't remember them all off the top of my head. We have -W for wordlist, so we'll specify user, share, wordlist, DirBuster, directory list, lowercase, medium. And then -U for the URL, so -U, HTTP, //10.10.10.34 -o for output file. We will call this GoBuster.log. And -t for threads will specify 25 threads. Let this run, and almost immediately we get a jail user directory. So let's see what that is. It's got a dev directory, so going in here, we see 3 files: compile.sh, a binary, and jail.c. So my guess is compile.sh is how we compile jail.c, which makes jail. And jail is probably listening on port 7411, and that's the port we didn't know from NMAP. Looking at these results, we see, let's see, first thing interesting I see is str copy. This is going to be buffer overflowable, most likely. We have a user pass here that is 16-byte buffer and password. Down here is 256. So a stir copy, we're copying password, which is a 256-byte buffer, to user pass, which is only 16 bytes, and that is where the buffer overflow occurs. We have a hard-coded username with admin and a hard-coded password with 1974 jailbreak. Scroll down. Right here is probably where user input is taken, and they're using strncomp here, so this one is not buffer overflowable. But if the token starts with user space, then strncopy, again, not buffer overflowable. Copy what's after user space to the username. Same thing here. If input begins with pass space, copy the what's after pass into the password variable. Then if it begins with debug, let's enable debug mode. So upon successful authentication, give 2 different things we can do. We can open doors or close doors, and we can look, almost nothing happens other than just printing out. So can ignore that. Once we're logged in, there's no good functions, just looking at that source. Scrolling down, we have, looks like socket stuff, so we're going to probably listen on the port like we thought earlier. It's going to be 7411. Down here, that's where it shows it. And that's it for the source code. So let's see what debug actually did. So there was a variable debug mode. Let's see what that mode does. If debug mode equals 1, print out the user pass buffer. And the user pass buffer, let's see where this is getting assigned, is just going to be that buffer overflowable thing and the input of password. So I don't know what the benefit of changing the password variable to be user pass is, but that's all that's happening. So let's create a new thing and download all the files. So make dir http, and then do a wget-r for recursive, http 10.10.10.34/dev jail user/dev. Download all the files and then go in to copy the ones we want out. So move compile, jail, and jail.c. And let's look at compile.sh. We have it doing -m32, so this can be a 32-bit binary, and -z exact stack. That's going to make the stack executable, essentially disabling dep. So the next thing I would do is probably set up a CentOS 7 box so we can do everything on that. You could probably do this on your Kali box or whatever OS you're doing because the binary is rather simple. But whenever doing any buffer overflow stuff, I always try to mimic the target as close as I can. So I have a CentOS box set up called CentOS 7, and let us copy files to it. So cd http. Over here, let's make the directory called Jail and SCP everything over to CentOS 7 Jail. Do a ls, go into jail, and then let's remove the jail binary because we don't care about that. We're going to create a new one, and go into compile.sh. Get rid of those because we don't need them. I'm going to add one flag, -g gdb. This is going to add a bunch of debug information to the binary that helps us debug it. So when we run compile.sh, we get a jail binary, and if we do gdb on jail, we have list, which gives us the source code of the binary, and we can actually just set a breakpoint on the line of C code so we don't have to go and analyze all the assembly to set breakpoints. It becomes very handy doing these type of things. So to begin the debug process, we're going to create a new window, SSH the CentOS server, and execute the program. The reason I'm doing this and not just using GDB to start it is I don't like using GDB to start programs. I rather just attach to them because GDB does a bunch of things to the environment prior to starting it, like disable ASLR and things like that, which can have negative impacts. So I normally start the binary and then attach the PID. So ps-ef grep on jail. It is PID 26606, so we can do gdb --pid 26606. The first thing I'm going to look at is the follow fork mode option in GDB. So this is going to be how GDB handles when a process forks. And it's going to follow that into the child process. That's good. The next thing we want to look at is what it does to the parent process. So I'm going to do show detach on fork. And we see it's going to detach from the parent whenever it goes into the child. We don't want that. We're going to set that to off. So now we can test everything if we continue a run by doing an nc 1010, or not 1010, the IP address of our Linux box, which is 192.168.101.142, and the port is 7411. We see the new process, GDB went into that. If we do user admin pass something, we get authentication failure, and then GDB doesn't go back to the parent automatically, so we can do info inferior, and we see the parent process 1, so if we do inferior 1, we're back into the parent. So if we go back to that port 7411, let's start off by saying debug, then user, if I could type, user admin pass, give it a pass, and we see the user pass buffer at 0xFFFFCE70. And I actually think GDB took over the memory address. So let's exit here, go back, pkill-9 jail, okay, ps-ef grep on jail, gdb --pid 26619, detach on fork off, C. So I think what I made the mistake of doing is I typed R, which killed the parent process and restarted it. So if I do nc 192.168.101.142, debug, user admin, pass, give it junk, there we go, 0xFFEB-B890. So now we're no longer in GDB land, we're just debugging the native process. So we can't use R ever. We always have to continue. And we can do inferior 1 to jump back to the parent PID, continue again, and we're good. So the first thing we want to do is start our exploit skeleton. Or actually, before we do that, let's see how many characters it takes to overflow the buffer. So NC again, let us send a new pane. What was it? User admin. We can actually do one thing before that. So let's background this, look at the source code, and let's set a breakpoint right after the buffer overflow. So on line 22. Okay, now we can continue. Pass, let's send it 40 A's, so python-c print A times 40. And since the user pass buffer is only 16 bytes, this should crash the program. So sending 20 A's, we get breakpoint 1 hit, and we can do x/10s to examine a space, and we can examine the password variable. And we see right at that memory address that A is repeated 40 times. If we want, we can look at hex, so 50 hex at that address, and we'll do 16 bytes before that address. So before that address, we see random stuff, then we see 40 A's. So we know at the address it's leaking that it's exactly what we put of the password. So if we put shellcode there and set EIP to that address, we could execute the shellcode and get code execution. So let's see. We got to go inferior 1 to jump back to the parent. And we want to, let's see. Let's create the skeleton exploit. So let's copy a bunch of text. That'll be handy eventually. And create a directory called buff, I guess. And we'll create exploit.py. So we're going to use pwn tools. The very first thing then would be from pwn import star. Then we got to set the basic stuff. So set basic junk. Context OS equals Linux arc equals i386. Then host port equals 192.168.101.142. The port is equal to 7411. Then the memory address leaked is going to be a 32-bit memory address, like that. And before, we need junk to get to EIP Overwrite. We actually don't know that yet. Memory address leaked, and then after that we need shellcode to execute, and we don't know that yet either. So the very first thing we have to do is connect pwn tools to the host, and we do that by p equals remote host port. And then once we connect, we are going to do p.receive until. OK, ready, send user command, and then we're going to send the line debug, and we want to send line user and send the pass. Okay. Then p.receive until. Okay, debug mode on, and then p.receive until there. pass, and then plus, what is it? Junk mem buff. So what that's going to do is set up a kind of an expect session to wait until we get the banner of the program, which is OK ready. Once we see that, we're going to send debug. Then we're going to wait until we see the program tell us debug mode is on. We're going to start logging in with user admin, then receive until it asks for the password and send the password plus all our junk. So the junk, we're going to get that by going back into GDB. Let's fork background that. Pattern, and it's create, and we'll give it 50 bytes. If we copy this, put this in junk, save this, and then execute our script, we have a breakpoint right away. If we examine that memory address we did last time, we see the buffers changed to be the, I think, cyclic redundant pattern or whatever pattern that GDB created. Let's continue this, and we get a crash. We have EIP crashing when A is AA semicolon AA. We're going to do pattern offset value. And you could use the MSF tools to generate all this. I just find it quicker to do it within GDB PETA since I don't have to switch programs. So we have the offset at 28. So after 28 bytes, we control EIP. So inferior 1, let's jump back to the parent. Go to exploit, and after 28 things, we get an overwrite. And I'm going to put the junk as \xcc, which is going to tell GDB if you ever hit this and execute this opcode, break. And yeah, the reason I do that is I never should jump into junk. And if I jump into junk, something bad happened, and I want the program to break instead of crashing because it's just more graceful and I can debug better. So we have the jump, the memory address, and we need shellcode to execute. So let's Google shellcode Linux reverse TCP x32 x64. Oh, not x64, crap. x32. Yeah. Then we want to copy the shellcode. Then I want to copy this URL. Reverse shell x32. And we have to make a few modifications. So the first modification is we don't want IP 127.111. And we see it's broken up a hex byte for each octet. 7F is 127 in decimal, 1 in hex is 1 in decimal, etc. So we want this to be 192, which is C0, I believe. 168 is A8. 101 is 65, I believe. And the last octet is going to be my IP, which I think is 143. It is 143. And 143 would be 8F, I think. Let's see. 0x, 8F to decimal. 143. Yep. So we got that correct. Then the port 555555 is good. And we should be able to run this. So let's open netcat session to listen on port Quint5 and execute this and see what happens. We get the breakpoint where we set it, continue, and then we hit stop reason sig trap. So we landed in the C's. So we landed in a junk, and I don't know why we landed in junk. Inferior 1, let's go back to the parent. And if we hadn't done that, we can show you what would have happened. So if you just did like A's, like most people, for junk, A's actually increment EAX and hex, so it's not going to be obvious we hit junk. So we just crash EBP. Let's see, EIP is this address. Yeah, it's not exactly obvious that we landed in junk since it doesn't break automatically. It landed in the junk, did increment EAX 40 times or 28 times, and then crashed. So having that as C's just saves you time. And the reason why we landed in junk is because the memory address is pointed right here. We have to add 28 bytes to that, then we're at memory, and if we add another 4 bytes, we're at the buffer. So if we do this address plus 32, let's see, inferior 1, continue, breakpoint, and we get a shell. Awesome. So now we just have to change this exploit to go against the actual server. And it's not going to work, but we're going to do it anyways, and then figure out what the issue is and fix our shellcode to do something else besides the reverse shell, because the reason it doesn't work is there's a firewall blocking us. So we can use a socket reuse, but we'll cross that bridge in just a few minutes. Let's port this shellcode to against the server and verify that we don't get a shell back when we go against the server. All we have to do is change the IP address. So we look at our ton0 address, which is the VPN. It's 10.10.14.12. So let's go into the exploit script and change the IP. So that IP was not 127.111. For documentation purposes, that was 192.168.101.143. And this IP is going to be 10.10.14.12. Those numbers are much easier to work with in hex. So 10 is A, so 0A, 0A. 14 is going to be 0E, and 12 is 0C. So when we run this, oh, we forgot one thing. The actual IP address of the server. So host port, that's going to change. And this is going to be Jail's IP, which is 10.10.10.34. So set our listener to be 5.5s and run the exploit. Open, and we don't get a shell. So that's a problem. We can't really see exactly what happened. And I noticed I missed one small thing. I thought it was a lot less changes than it actually was. But one small detail that we need to do, connect to it, do debug, user admin pass, send it some junk, and copy the password buffer. So that it's FFFF. Oh well. Won't think too much of that. I thought it wouldn't be that. Let's see. Paste. And let us put the new memory address. Whoops. We can call this lab, and this will be HTB. So we're still listening, run the exploit, and we don't get a shell. So Now we have to kind of think of what we can remove to take out any unknown variables. And we can remove the entire creating another connection because we can reuse the same socket we have doing the netcat. So right when we hit this buffer overflow, so if we did user admin pass and we did the buffer overflow here, and we gave it the correct magical address, instead of just crashing, we could have it jump to a shell and send that shell over standard out and standard in. And that's a lot easier done, actually, than said. So we just go back to Google, and we can Google socket reuse x32, probably. Probably should have done shellcode. Shellcode, and go here. Take the shellcode out of here, which is much smaller than the reverse shell, because we're not dealing with the TCP stack at all. And let's make this bigger. Socket reuse x32, paste. And add a few things. I don't know why I copied a blank line there, but I did. Clean that up. Coming out this one. And we just need to add a p.interactive at the bottom. So that's just going to tell Pwn Tools to drop to an interactive mode. Don't wait for anything. Just give us a shell like we were connected to netcat. So it drops out of expect. And let's try that. Python exploit, switch to interactive mode, and if we do ls, we have a shell. And do ID, we're running as nobody, and our context is here, which we're not really used to seeing. This is a SELinux thing. I forget the terminology. I want to say it's called labels, but I would definitely Google it. I'm not a SELinux expert. But I do remember reading about a SELinux bypass on NetSec a few months ago, or maybe a year ago. So if we just do site reddit.com/netsec and do SELinux Escape, brings us right to the CVE. And going in these comments, they probably explain it better than I ever could. Too long, didn't read. Stuffing the terminal input buffer with commands to be handled by the process that runs after the sandbox finishes. And it's essentially the most interesting command injection I have ever seen, says the user deleted. So, such a good comment, and deleted his account or whatever. But let's follow that link to get the actual exploit. And going back to a shell, let's see. Before we do that, let's clean up this. We don't need this session anymore. Not letting me kill that, so just create a new window. And let's test out the NFS stuff. And when I was doing this box the first time, I immediately jumped to NFS as soon as I had a shell. And the reason for that is I knew NFS was open, and I knew it was version 3. And version 3, you can spoof that user ID. So it isn't uncommon to come across a system where you can mount something as NFS version 3, create a SetUID binary as root, chmod it with that SetUID permission, and then execute it for easy Privesc. So that is why I jumped to NFS immediately, and why we're going to begin looking at it now. So let's go back in the NMAP scripts, and we see the basic NMAP just shows NFS version 3. So what we're going to do is run a command called show mount, and then -- help. We want to use the -e flag or -- exports on 10.10.10.34. That will tell us that it has opt mounted and var NFS share mounted. If you see DNS names or IPs here, those are the ACLs on what can mount the share. All of NFS is based upon the IP address or DNS name in terms of permissions. NFS version 4 does have things like Kerberos for authentication, so you actually have user-based ACLs, but version 3, there's no ACLs whatsoever. That's all client-side. The other command you could run is like a show mount -a to see all the mount points on a share. Sometimes this command won't work and things will still be mounted, but the reason this is beneficial is if there was a home directory mounted on NFS, it may be possible to drop a SSH key, view the mount points, and start SSHing to servers if they have the home directory mounted as an NFS share, which does happen. So first step is let's actually mount these shares. So I'm going to do make dir /mount jail, and in the squiggly brackets I'm going to put opt and NFS share. And that's just going to make 2 directories. And we don't have a parent directory created in mount, so I'm going to add that -p flag to create that automatically. And if we do ls/mount jail now, we have 2 flags. So if I do mount -t NFS -o vers equals 3, that's going to say specify version 3 on the NFS mount, and we're going to say 10.10.10.34/opt goes to /mount jail opt. We're going to do the same exact thing for NFS share, and this one is going to be mounted var NFS share. There are tools out there like NFS Shell and NFS Spy to do all this for you and automatically spoof user IDs, but I have had plenty of times when I used NFS Spy and it accidentally deleted the file instead of writing to the file, which can cause issues. So I like using just stock binaries whenever possible, not having to go a hack around way to do something that I can easily do without a program. Just experience less weird issues that way. So if we go into those, if we go cd /mount jail and do find.-type f to see if there's any files we have access to, and we get permission denied everywhere. So we can't access any files. If we go into ls-la, we can see root owns NFS share and root owns opt. And if we look, we have a group ID of 1000 is the group owner of this NFS share, and it has write access to it. It can't read, but it can write. So it's saying 1000 means our Linux system doesn't have that UID, so I'm just going to change a user to be that UID. I got the IP user in etc passwd. I'm just going to change that to be 1000, and we're going to go into groups and change my permission to be 1000. So now when I do a ls-la, my box is telling me that IP has access to write in NFS share, or users of the group IP. So if I do su-IP to switch my user, I can go cd mount jail NFS share, and we can touch a file. So touch file write test creates that file. We could go to the shell and do a file on var NFS share for short memory span. File write. And we see the file does exist. We could also cat the etc exports and see what permissions are set on this. So because root squash is enabled, that means we can't spoof the root user. Whenever we remotely access something as the root ID, it maps it to, I believe, nobody. So that's what squash does. The no all squash says all non-root users don't squash the permission. So that is why we can now take ownership of this file write test file. So if we do a ls-la on it, we can see read write owner and then read other things. So changing here, we do chmod 4755 on file write test, do that ls-la again, and we see we now have read write and a special permission, which is a SetUID. So that has been done. my next step would be to go back to this pane, and we'll create a file called id.c. I actually don't like that. ip-id.c. And the contents of that is going to be simple. It's going to be int main void, and then set UID 1000, set GID 1000, system ID. And when writing C code, never ever not use a full path there. I think it's the lazy video. I go into why. Always use absolute paths if you're actually writing secure code, because you could just hijack that path. So that file should be written. For good measure, we'll see if this server has GCC. It does. We could compile it on a HackTheBox, but might as well compile it on the server if it has it. So var NFS share, what was it? ip-id.c -o var NFS share ip id. And no file. Cat ip-id.c. It exists. Oh, I'm guessing because we have nobody and we can't write there. So what we're going to do is just compile it on a HackTheBox and hope for the best. If not, then we can compile on a CentOS box and copy it over. But it's not doing anything special, so I imagine this is going to work. Those are just warnings, and that is fine. So chmod 4755 on ip-id. And go over here and execute it. So var NFS share ip-id. And it doesn't do anything. So if we look at that, var NFS share ip-id, we can see it should work. The last thing we could check is, do we have access to the mounts command or mount? We do. Let's do mount and grep for no SetUID. And we can see sys won't work, proc won't work, dev, sys, dev, run. These are all just directories where SetUIDs are prohibited. We don't see var or NFS share there, so it should work, but SELinux is preventing us. So let's go back to this exploit and see if this works. So we'll do se bypass-id.c. I hate clipboard sometimes. Set paste. There we go. And then we can do gcc se bypass-id.c -o se bypass-id. And we'll chmod it to 4755 se bypass-id. Did I typo something? I think I did. Let's just copy this. Function, warning. Oh, error. I guess I miscopied a... Probably didn't copy the whole thing and missed the libraries. Yeah. So we need to copy these. Reading is a very valuable skill to have. Where's the GCC? There we go. Just copy this. There we go. That worked much better. And then we can chmod that to give it the SetUID permission. Then go over to our Linux box and do se bypass-id. And we see the output changed slightly. We now have that EUID as Frank, which is effective user ID. So we have escaped this SELinux sandbox, and we're now Frank. Again, if we just ran IppID, we don't have that effective user ID. So the next thing is to change that. And we're going to make this, let's see, bin copy. And the reason why I was using ID to prove my user instead of like a shell and just hoping is because I have no idea how my TTY is set up doing this interactive thing and didn't want to do the Python import TTY stuff. So ID was a simple way where I don't have to deal with that. It's always best to make things as less, less complicated as possible. So I'm going to CP a file, and the magic file we can CP is a SSH key that we will have to create after we type this. So we'll create a key in, let's see, var NFS share /.ip.key. And we're going to copy that to /home frank.ssh authorized keys. And is that a period, not a comma? I think that was. Okay, that looks good to me. Let's generate a key. So SSH-keygen. Directory we want to save the key. We'll do root documents HTTP boxes jail frank dot frank dash key. That looks fine. We don't need a passphrase, and the key has been generated. So let's cat frank-key.pub. Copy this. Go over to our server, and what was it? .ip-key is what we called it. Look at this SC bypass file again. That was sloppy, not giving it a different name. It is .ip.key. And I called it ip-key, so we'll change the dash key to be .ip.key. Okay. Again, run GCC again to compile this, and we'll say, call this drop key. Wrong pane. Var NFS. I think I forgot to chmod it. Okay. Execute the file. And now we should be able to SSH with that private key. So SSH-I frank-key, and we'll do frank at 10.10.10.34. And we get in right away. So now we have a shell on the server as Frank. Because the next step in Privesc is something I would generally do before even running scripts, and this video is getting long, I'm going to skip running lin-enum and lin-privcheck. If you want to see those scripts, look at another video. But the first thing I do when I get a user account is sudo-l. We see that Frank may run sudo as the Frank user to read opt logreader logreader.sh. Seems like a red herring. Why would Frank want to switch to the Frank user to execute a script? We can look at that script anyways and see what it does. And doesn't look vulnerable at all. It's doing a cat against a log file, and cat is an absolute path. So I don't think I can do anything there. We could check its permissions. I can't even write to the file, so I'm going to ignore that right away. We can switch to the ADM user and execute rvim and edit the jail file. So let's check that out. So we'll do sudo -u adm, and then the command we're allowed to run. And instead of changing anything right away, we notice we're in a VI session, and with VI, we should be able to just do :python and break out. So if we do import pty, pty.spawn, bin bash, we get a shell. Hit enter a few times to clear that, and we do ID, we see we're now ADM. So we just used VI to execute a command. You can do a lot of the similar things in like less, I believe, and whatnot. Be careful who you give sudo access to in general. I think you're supposed to use like sudo edit or something that may fix it. Can't remember off the top of my head, but just unintended effects of getting sudo to, or the sudo ability with VI. But now that we're the ADM user, I'm going to look at the home directory of ADM to see what I have access to. And we'll do find.-type f. And we see there is a .keys directory with note.txt, .local.frank, and .keys and keys.rar. So this file is actually encrypted. If we wanted to verify that, we could do like unrar x to extract and paste that file, and we get a password. So if we cat this note.txt to see what this reveals, Frank, for the last time, your password for anything encrypted must be your last name followed by 4 digits and a symbol. So we could just start brute forcing from here, put a bunch of last names and create that word list, but let's see what this .local.frank is. So if we cat that, we see something that's definitely obfuscated. I don't think it's encrypted because SZ doesn't seem like much entropy. It screams like rot13 or something that the same operation is being done on every character just based upon the repeat. That looks to me like ha 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 ha. The reason why it's not rot13 right off the bat is Z to A is just one character difference, not 13. So we can just send this to Rumkin Cipher. It's a good tool that has a bunch of online ciphers, and if we go to rot13, it's nothing. Rot n encoder, and we can just go through all the rotations, seeing if we see anything. We got ahaha, and then junk, so that's not it. Keep going down. Ho ho ho, nothing. And going through all the transitions, we don't see anything. So when I start thinking about other tools to run, or I would just go to like, I think it's Quip, I think that's the right spelling. And then we'll use this site to solve it, which essentially just bubble stores everything, I believe, and it gets it pretty quickly. If you wanted to do it, you think, what could Z be to turn it into A? And I would just think like an @bash cipher, which essentially inverses every character. Z goes to A. I can't think of the alphabet backwards, but B goes into Y. That's it. And we paste that in the cipher, and we get it there. So that was @bash. Haha. Nobody will guess my new password. Only few lucky souls have escaped Alcatraz alive like I did. So we can just Google Alcatraz escape. Go to here, and let's see. It lists a few people. We have Frank Lee Morris, John William Anglin, and Clarence Anglin escaping Alcatraz. Since our usernames is Frank, I'm going to guess it is going to be Frank Morris as the person that has escaped Alcatraz. So, first thing I'm going to do is read this note again. We're going to guess that the password is going to be Morris, 4 digits, and a symbol. So let's copy the RAR file to a server. The easiest way to do this is just base64 the file. We could use SCP since we have the key, but I find this relatively easy to do on small things. So copy that, open a new terminal. We'll call this keys.rar.b64. Paste base64-d on that file to be just keys.rar. md5sum. That's the wrong window. md5sum on keys.rar. fe1 and ends with 86. fe1 and ends with 86. So we got the file there. We're going to use a tool called John2rar. I thought I had it, or maybe rar to John on that directory, and we get something that is friendly with JohnTheRipper to crack. One key thing is this isn't actually implemented in Hashcat yet. I checked, and how I did that was I went to Google, Hashcat example hashes, gets us to the page, and I Google what I think is a unique identifier is rar3, and that gives us the sample output that would be, we have rar3, 0, then just very few parameters. If we look at this hash, it's 1 and then a lot. So the next thing I did was, I think I just Googled this with Hashcat and look at the feature request. And we see it's help wanted new algorithm and talk about implementing this. So this portion isn't actually in Hashcat, but we can use JohnTheRipper to crack it. So let's go to my cracking server, and I'm still going to use Hashcat to generate the word list just because I'm familiar with Hashcat rules and not John rules. So we want to create a targeted word list with Morris, 4 digits, and a symbol. So we're going to go into the Hashcat directory, execute hashcat -help, and go to the bottom. We're going to want to use the brute force attack mode, so -A3, and we can see how to use it. We have $A. What that means is go up to these character sets, and $A is going to brute force all lowercase letters, uppercase letters, digits, and symbols. We don't want that in it. We just want to do 4 digits and a symbol. So if we do /hashcat --std out, that's just going to output stuff to standard out. We don't actually have to crack a hash with it. This is relatively new. It was always in the Hashcat for CPUs, wasn't in OCL Hashcat, and version 3.0, they merged those two branches, and -s std out became available for everything, and it's been amazing to create word list. So it was Morris, and for time's sake, I'm going to put the 19 in because I know the first 2 digits are 19. Then we'll do 2 digits and a symbol. I'm going to direct that to a file /root/john. We'll do jail.words. And I think that's it. And while that copies, I want to grab that rar to John output. So I don't think I copied it to a file. And we'll do v root jail.hash. Can't open file for writing. What? I'm root. Oh, wrong path. It's been a long video. Jail.hash. There we go. So if we cat jail.words, we have Morris, 19, 2 digits, and a symbol. I really hope it's 19, not 18, but we'll find out, I guess. Go into the JohnTheRipper folder. I think I have the binary under run. Do I have it under opt? Is that the most recent one? I can't remember what is the more recent copy of John. ls-la John, ls-la opt John. July 16th versus November 14th. November's more recent, so I think I'm in the correct directory. Would help if I was a bit more organized. So John -- wordlist equals root / John jail.words, and we want to crack jail.hash / root jail.hash, and or OpenCPL loaded one. I think it was in my pot file to begin with. Do I have a pot file here? MV john.pot to john.old, and we'll try cracking that again. I could have just done -- show, but what happens is when you crack something successfully, it puts it into a file so it doesn't crack it again. So this should crack relatively quick with that. Yep, so we got it. Morris 19162. So if I ran that again, it would instantly finish. And if I wanted to, I could do -- show. Maybe you have to get rid of that word list option. Yeah, and it would show it that way. So we have that password, Morris 1962. So if we do unrar x on that archive, paste the password, it extracts root authorized SSH key.pub. And I'm not going to go into all the RSA specifics. I think this was done on the Brainfuck video if you want to watch that and get into more how RSA works. But we're just going to use a tool called RsaCtfTool. And that does a lot of common attacks against RSA. If I do -- help, I think it'll output the options. I think I need the public key and private option. Let's see. Yep. So I'm going to tell it we have a public key, and the public key is root authorized SSH key.pub, and we'll do -- private, and we can do -- verbose to see what it does. Verbose isn't needed, but I just like throwing it. And we see it's doing the wiener attack, and we'll see if it gets it. I hope it gets it. Pretty sure this is how I did it the last time. Yep, there we go. Begin private key. We'll copy this to a file. So we'll do root - key, paste, chmod 600 on the key, sh-i root - key, root at 10.10.10.34, jail's IP, and we get in as root. So that is the jail box. I hope you guys enjoyed the video, and yeah, take care. Actually, I lied. We're going to add a little bit of a special bonus to the end of this. After I recorded the videos, I was talking to NoDecaf, and someone actually found a really cool unintentional way to Privesc to the ADM user using NFS. So we're going to show that method off because it definitely changed my understanding of how the SetUID bits work in Linux. So yeah, let's jump back in. So to get to a spot where we can easily continue working on it, we need to SSH into the jail server as Frank, which is the unprivileged user. And we need to verify we still have the NFS server mounted. So we can do a mount grep for NFS, and we see it is indeed mounted. Let's switch over to IP, which is UID 1000. That is the user Frank on our NFS server. If we go into var NFS share, mount jail NFS share. On the server, if we go into var, do a ls-la, grep for NFS, we can see only the Frank user can write to this box. Of course, root can, but on this directory, only Frank should be able to write to it. And because ADM or other users couldn't write to it, we couldn't escalate to their user. However, if we create a directory, let's say IppSec, and chmod that to all 7s, now any user can write to this directory. And we can verify this by switching over to a root user who, again, cannot write to NFS by default because there is the root squash on that etc export. So the root user is mapped to a nobody user. So we can verify that in this NFS share. Can't write, but if we go into the IppSec directory that we just created and chmoded to all 7s, we can write there. And going into NFS share IppSec, we can see NFS nobody has created a file. So what we have to do is now cat the etc passwd for the ADM user, which is going to be UID 3 and 4. Go to etc passwd on rbox and change IP to be 3 and 4. Let's go into group and see what 4 is on group. It is ADM as well. So we can switch to IP again, go to mount jail NFS share IppSec, touch test, I guess 3 maybe, or is it 2? I lost count. But test 3 is now owned by ADM. So we have now created files as the ADM user on that NFS share. The next thing we have to do is create a SetUID program. And this is going to be a little bit different than all the previous SetUID programs I've done in the past because I completely misunderstood SetUID. So we'll go over that right after I manage to type this out, hoping I don't make typos and have to debug this. And this program actually came from NoDecaf. I'm not taking credit for writing this because, again, I completely misunderstood SetUID. Okay, so that should do it. The main difference with this program is we are using a exec call instead of system. And the reason we're doing that is because system drops effective user IDs from programs. And effective user ID is how SetUID works. If you just have a file owned by root, you can just do a SetUID and it changes the owner to root. If the file is owned by someone else and you want to take advantage of a SetUID bit, it sets the effective user ID, which system drops, exec does not. So that is the key. Also, kudos to whoever found this unintentional Privesc method. It is definitely a hidden gem that I learned a lot from. And I got the misconception about SetUID because, in my defense, reading this, SetUID sets the permission of the executable's owner group. And yeah, it's just where my misunderstanding came from. Didn't read exactly how everything worked underneath. So maybe you guys learned something there too. But let's show exactly how it works. So gcc setuid.c, we'll call this SUID. Create the file chmod 6755 on the binary. And this first bit, when we have 4, this is the special permissions bit. 1 is sticky bit. 2 is set GID. and 4 is SetUID. So when we add both SetUID and SetGID, we get 6. So that is why this is 6. Then read, write, execute, read, execute, read, execute. So if we go back here and do a ls-la, we see the SetUID binary is owned by ADM, and we have the special bits set. So if we do /suid and ID, we get our effective user ID as ADM and effective GID as ADM. So now we can do suid find /var ADM, and we have access to this directory. And again, our user doesn't have access to directory. If we just ls or something, we get permission denied. So that's pretty cool. Another neat trick with this SetUID program is, I think when I was doing the SELinux portion, when I do that exec call, I can't use like pipes or directs in the actual binary because that breaks it. Hard to explain why, I don't really fully understand, but there is a neat trick. So if we do like echo test and we put the pipe to the SetUID and call the program T, which is going to take whatever is in standard out and direct it to a file, we can actually write files without making the SetUID on the other side of a pipe. So we'll make the file IppSec, and we'll put no decaf rocks. And I keep calling it SetUID. I actually type SetUID. It's just SUID. So if we look in /temp now, we have that file IppSec, and it is owned by ADM. So as Frank, we are able to use the exec call within SUID to write a file, which is awesome. And we can now cat temp IppSec, and we get no decaf rocks. So what this would have allowed us to do is be less destructive in the previous test when we just copied the key. Because when I copied my SSH key into authorized keys, it clobbered authorized keys and only wrote my key. If we had done it this way, we could probably do like T, and I think it's -A to append. If I could type. Yeah, -A to append. So if we just do T-A and we cat temp IppSec, we now appended a line. So going back, I would have echoed my public key as Frank and did a T-A to append the SSH key to the authorized key file, so I didn't clobber it if it was there. Because again, deleting files is always bad. And you may be wondering why we didn't just copy a SSH key as the ADM user. I kind of glossed over that. If on the server we cat etc passwd and grep for ADM, we see his shell is sbin no login. So even if we could write the SSH key, we don't have a shell to log in as. So I hope that was beneficial, and take care, guys. This time I am gone for real. Well, until next week. Bye.